Nuclear fusion and the recent breakthrough. Nuclear fusion is defined as the combining of several small nuclei into one large nucleus with the subsequent release of huge amounts of energy. On Tuesday, the Lawrence Livermore National Laboratory in California announced that an experiment carried out in its National Ignition Facility has made a breakthrough in nuclear fusion research. In the experiment, lasers were used to heat a small target or fuel pellets. These pellets containing deuterium and tritium fused and produced more energy. The team noted that they were able to achieve yield of more than 1.3 megajoules. Professor Jeremy Zitten, co-director of the Center for Inertial Fusion Studies at Imperial College London, told BBC.com, "The megajoule of energy released in the experiment is indeed impressive in fusion terms, but in practice, this is equivalent to the energy required to boil a kettle." So, what exactly is nuclear fusion? Nuclear fusion is defined as the combining of several small nuclei into one large nucleus with the subsequent release of huge amounts of energy. Nuclear fusion powers our sun, and harnessing this fusion energy could provide an unlimited amount of renewable energy. The 2018 book Comprehensive Energy System notes nuclear fusion energy is a good choice as the base load energy in the future, with many advantages such as inexhaustibility of resources, inherent safety, no long lived radioactive wastes, and almost no CO2 emissions. How was the new breakthrough achieved? The team used new diagnostic, improved laser precision, and even made changes to the design. They applied laser energy on fuel pellets to heat and pressurize them at conditions similar to that at the center of our sun. This triggered the fusion reactions. These reactions released positively charged particles called alpha particles, which in turn heated the surrounding plasma. At high temperatures, electrons are ripped from atoms' nuclei and become a plasma or an ionized state of matter. Plasma is also known as the fourth state of matter. The heated plasma also released alpha particles, and a self-sustaining reaction called ignition took place. Ignition helps amplify the energy output from the nuclear fusion reaction, and this could help provide clean energy for the future. On August 8, the team noted an energy output of more than 1.3 megajoules. The findings are yet to be published in peer-reviewed journal. This is a major breakthrough as the output is higher than the previous highest energy achieved. Previously, laser fusion program faced several difficulties as we were not able to completely understand the plasma. Now, new technologies have paved the way for these amazing findings, and it has also given us hope that we are in the right direction, says Dr. G. Ravindra Kumar from the Ultra Short Pulse High Intensity Laser Laboratory at the Tata Institute of Fundamental Research, Mumbai. Dr. Ravindra Kumar, who was not involved in the experiment, added that more studies are needed to break even for a power plant to work. We need to generate much more energy for a power plant to work successfully. Nevertheless, this is a substantial step forward and a technological breakthrough, he adds. Dr. Aidan Crilly, Research Associate in the Center for Inertial Fusion Studies at Imperial, noted in a release, reproducing the conditions at the center of the sun will allow us to study states of matter we have never been able to create in the lab before, including those found in stars and supernova. We could also gain insights into quantum states of matter and even conditions closer and closer to the beginning of the Big Bang. The hotter we get, the closer we get to the very first state of the universe. Thank you.